In this second video, we will talk about pressure in liquids. Pressure is not only exerted by solid or in solids, it's also in liquids. The weight of the liquid causes pressure in the container. It also causes pressure of an object in the liquid. So pressure increases with depth. Let's see this. Liquids exert a pressure on the walls of the container and any body immersed in them. As we know that pressure equals F over S. So, force exerted in this case will be the weight of the liquid. Weight means M times G over the surface area. M, we all know that it's density times volume times gravity over S. The red one, M, equals density times volume. What about volume? Volume equals that in purple. S times H. You know that the volume is the surface area times height times G over S. S and S will be eliminated. So pressure in liquid will be density of liquid times gravity times height. So if we change the density of liquid or the height, the pressure exerted by liquid will be different. Now let's see this one. This is a beaker. At this beaker, it's filled with water to a certain level. We assume that no atmospheric pressure in this case. What is the pressure exerted by liquid at the surface? At the surface, if we are swimming at the surface of the pool, swimming pool, are we subjected to pressure by liquids? No, because we are at the surface. So we can see here that the pressure is zero. As we move down, observe the pressure. As we move down, the pressure is increasing. So as the height, depth in this case increases, the pressure will increase. Which pressure? Pressure exerted by liquid only. Pressure exerted by liquid. So, variation of pressure with depth. As we can see here, observe this figure. A is at a height HA from the surface of liquid. B is at a depth HB from the surface of liquid. In your opinion, which point is subjected to a higher pressure? Of course B, because it's deeper. So PA equal density of liquid times gravity times HA. PB, density of liquid times gravity times HB. The difference in pressure between these 2 points will be PA minus PB, density of liquid times gravity times, take common, density of liquid times gravity, it will be HB minus HA. HB minus HA, the difference is H. Pressure of all points in a horizontal plane in a liquid at rest are equal. So A, if we have point C here, point D next to it, all these will be subjected to the same pressure exerted by a liquid. This is what I was talking about. These 3 points at the same level are subjected to the same pressure exerted by liquid. The more we move down, pressure will increase. Okay, is it clear? So, let's say that an object is at a point here, A, and another object here, another object down. How to determine the pressure, variation in pressure or the difference in pressure? I have to subtract 19,502 from 9,935, and this will be the variation in pressure between these 2 points. Now, Pascal's theorem. Pascal's theorem states the following. Liquids transmit wholly to all points and in all directions any pressure variations they undergo. You have to memorize this. What does it mean? Let's say, or let's assume that I squeeze this balloon. The more you squeeze the balloon, the more you will notice that more quantity of water will move out of the balloon. This is what is meant by the concept of Pascal's theorem. So the pressure exerted at this point leads to the motion of water at a different point. Or let's say that you jump on a banyan. As you put your leg, you will notice that the level of liquid increases. You put the other leg, level of water increases more. If all of you is immersed in liquid, the level of water, or totally immersed, the level of water will be maximum. So the pressure you are exerting at a point is transmitted by means of a liquid to all points in the beaker or in the container.